Okay. So second row become second column. Second row become second column. Same way third row is 2 minus 4, 1. It will becomes third column, 2 minus 4, 1. Now compare A with A dash. See here, both of these two are same. So which is equal to, that means A. Now simply by seeing the matrix, we can directly say that this matrix is symmetric or skew symmetric, or not skew symmetric or skew symmetric. See here how we can able to know that. So at first you have to see the diagonal, you have to write the diagonal elements. You can put any numbers. Here I put 3, 5 and 1. You can put any numbers. Okay, these diagonal elements. After that you have to check this number. Okay, this number will be same. If you put here -1, this will be also -1. If you put here 2, this number will be also 2. Again, if you put here -4, this will be also -4. So then you will directly get a symmetric matrix. Okay, you will directly get a symmetric matrix. Next, see here, what is a skew symmetric matrix? What is a skew symmetric matrix? So a square matrix is called skew. Don't make noise. You can ask me any question, there is no problem, but otherwise don't make a noise. Okay. Next, see, a square matrix is called skew symmetric matrix. A square matrix is called skew symmetric matrix if A dash equal to -A. So if A dash equal to -A, then the matrix is called what? Skew symmetric. So I take this one is example. A is a matrix. So if you transpose this matrix, you got this one. Okay. Transpose this matrix, you got this one. After that, see here, whenever we take common minus sign, then 0 will become 0. This +4 is there, so that's why here we have to put -4, so that minus it will become plus. Again, this is +5, so that's why it is -5. Since it is -4, it will be 4, so proceeding in this way. Okay, now compare this one with the matrix A. See here, this one and this one is same, so we put here -A. So A dash equal to what you got? -A. So this type of matrix is called what? Skew symmetric matrix. So now we have to know how we can form a skew symmetric matrix. It is very easy. See here. So at first you have to write the diagonal elements. Okay. And one thing you have to remember, in case of skew symmetric matrix, the diagonal elements are always equal to 0. Okay. In case of skew symmetric matrix, the diagonal elements are always equal to 0. And rest these elements are, this 4, -4, these elements are what? Opposite in sign. Okay, if it is 4, it will be -4. If it is 5, it will be -5. If it is -8, it will be 8. Clear? Diagonal elements always you have to choose as 0, and rest these elements are what? Opposite in sign. Okay, so in this way we can form a skew symmetric matrix. Now it is Hermitian and skew Hermitian matrix. Hermitian and skew Hermitian matrix. Okay, so see here. A square matrix A is called Hermitian matrix if A to the power theta is equal to A. Okay, so A to the power theta means what? It is A bar whole dash. Okay. That means at first you have to take the conjugate. After that, you have to take the transpose of the matrix. Now see what is conjugate of an element. Suppose x is a complex number 2 plus 3i. X is a complex number 2 plus 3i. So if you take the conjugate of x, then what happens? The sign of the real part is remains same and the sign of the imaginary part is changed. Okay, so when we take the conjugate of a number, what happen? Sign of the real part remains same and the sign of the imaginary part is changed. Okay, now see here, I give one example. So Hermitian matrix means what you got? If a theta equal to, you got a. Again, a theta means what? A bar whole dash. Okay, so I take one example. See here, this is a matrix. So at first we take the conjugate of a. So 2 is a real number, so there will be no change. Again, 2 minus I. So in this case, what happened? The sign of the real part remains same and the sign of the imaginary part is changing. It is plus I, it is minus I. Okay, and this real part 4 is remain as 4. Again, this is 2 minus I, so sign of this part is changed, so it will be 2 plus I. This is 3, it is again 3. It is I, so it will be minus I. It is 4, same as 4. It is minus I, sign will be changed, so it is I and 1. Okay, so see, I already told you, at first we have to take the conjugate. After that, we have to take the transpose of the matrix. Okay, after that, we have to take the transpose. Now we take the transpose of A bar. So this first row becomes what? First row becomes first column. So what is first row? 2, 2 minus I and 4. It will becomes first column. 2, 2 minus I, 4. Again, second row become second column. This is 2 plus I, 3 minus I. It is become second column. Same with the third row. What is third row? 4 I, 1. It will again become third column. Now compare this matrix with the given matrix A. See here, both of these two matrices are same, is it? So A dash bar equal to what you got? A. So that's why we can say this matrix is Hermitian matrix. Okay. So now main thing is, how you able to know that after seeing the matrix, how you able to know that this matrix is Hermitian or not, or skew Hermitian? Actually, by seeing the matrix, we can directly say that this matrix is Hermitian or skew Hermitian. Okay, see here. So in case of Hermitian matrix, at first you have to put these diagonal elements. Okay, and in case of Hermitian matrix, the diagonal elements are always real numbers. Okay, the diagonal elements are always real numbers, and these elements are you can put imaginary number also, real number also. Okay, now see how we can put those numbers. So here what happened? Here we put 2 minus I, here we put 2 plus I. That means what? The sign of the real part remains same, but the sign of the imaginary part is changed. Here we put only the real number, so there will be no change. Again, here we put only the imaginary number, so that's why here we put I, here we put minus I. Okay. So by look at the matrix, we can directly say that this matrix is Hermitian or skew Hermitian. Now see, what is a skew Hermitian matrix? Skew Hermitian matrix. Okay, see here. So what is this given? A square matrix. A square matrix is called skew Hermitian if A to the power theta equal to minus A. Okay. So if a to the power theta equal to minus a, we can say that this matrix is what? Skew Hermitian. Okay. So a to the power theta means, I already told you it is, we put a bar whole dash and this is equal to minus a. So if we got a bar whole dash equal to minus a, then we can say that a is what? Skew Hermitian. Okay. So at first we take what? A matrix. We take a matrix. Clear? So after that we have to take the conjugate of this matrix. See here, a bar. So 3i is there, it will be minus 3i. Again, minus 4 minus I whole bar. So sign of the real part remains same, but what happened? The sign of the imaginary part is changed. Since it is minus I, it will be plus I. Again, minus 2 plus I, it will be minus 2 minus I. Okay. Again, 4 minus I, it will be 4 plus I. 0 is remain as 0. Again, I will becomes what? Minus I. So 2 plus I will becomes, if we take the conjugate, it will be 2 minus I. Again, I bar equal to what? Minus I. Minus I whole bar equal to what? I. Okay. So after we have to take the transpose of the matrix. Okay. We have to take the transpose of the matrix. So first row become first column, see here. Second row becomes second column. Third row becomes third column. Okay. Third row becomes third column. Now you take common minus sign. See here, from here, if you take common minus sign, then it will be 3i. It will what? Minus 4 minus I, because you multiply by minus, it will be plus 4i, 4 plus I. Same way, this will be minus 2 plus I. And this will be 4 minus I. It will be 0, I, this one. Okay. Now, as a whole, if you take common minus sign, so now compare this one with the given matrix A. This both of these two are same. Okay. So this is equal to minus A. So this type of matrix is called what? Skew Hermitian matrix. Clear? Now by seeing the matrix, see how we can directly say this matrix is Hermitian or skew Hermitian. Okay. So at first you have to know that the diagonal elements of a skew Hermitian matrix is always either 0 or purely imaginary number. See here, the diagonal elements of a skew Hermitian matrix is always either 0 or purely imaginary number. See here, here we put 0, here we take 3i, here we take minus I. That means these are purely imaginary. And these elements, for these elements, we have to consider the sign of the imaginary part is remain same and the sign of the real part is changed. Here we take 4 minus I. So here you have to take minus 4 minus I. Here we take minus 2 plus I. Here you have to take minus, in place of minus 2, you place 2 plus I remains same. That means sign of the imaginary portion remains same and the sign of the real part is changing. Okay. So in this way, we can directly say that the matrix is Hermitian or skew Hermitian matrix. Now someone tell me what are the diagonal elements of skew symmetric matrix? What are the diagonal elements of skew symmetric matrix? Yeah, tell me, anyone. At first, unmute yourself and tell me. Nihar Deka, please tell me.
0, sir.
What are the diagonal elements of a skew symmetric matrix? It is
0.
Yeah, 0. And for now, Suraj, tell me what are the diagonal elements of a Hermitian matrix? Suraj. At first, unmute yourself. No response. Riyam Deka. What are the diagonal elements of a Hermitian matrix? Anyone tell me? What are the diagonal elements of a Hermitian?
Real number, sir.
Yeah.
Real number.
Good. Diagonal elements of a Hermitian matrix is real number.
Real number.
And what are the diagonal elements of a skew Hermitian matrix?
0 or pure imaginary number.
Good. Either it is 0 or pure imaginary.
Pure imaginary.
Okay. Now come to the next topic. Idempotent matrix. Okay. Idempotent matrix. So a square matrix is called idempotent matrix if a square is equal to a. Okay. If a square is equal to a, then the matrix is called what? Idempotent matrix. So I give an example here. A square means what? A into a. So we multiply these two matrix. Simply here I given the first row. This is 2 into 2. It will be 4. Again minus 2 into minus 1. It will be plus 2. Again minus 4 into 1. It will be minus 4. Same way we multiply this and we got this result. Minus 2. After multiplying this, we got this one. 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. That means compare with A. This is the same matrix. Compare with A, it is the same matrix. Okay. So this type of matrix is called idempotent matrix. If A square equal to A, then this kind of matrix is called what? Idempotent matrix. So next one is nilpotent matrix. Nilpotent matrix. Okay. So a square matrix is called a nilpotent matrix if a to the power k equal to 0 for some positive integer k. The smallest such k is called the index of A. So I give one example. See here, suppose this is a matrix A. If you squaring this one, then A square you got this is equal to 0. Okay. So that means index of this matrix is 2. Now listen to me carefully. Suppose you got a matrix A where A to the power 4 is equal to also 0 and A to the power 7 is also equal to 0. Okay. So now which one is less than? 4 is less than to 7. So that's why that 4 is called the index of the matrix. Okay. That 4 is called the index of the matrix. That means the smallest, listen, the smallest value of k for which A to the power k is equal to 0 is called the index of the matrix. And this kind of matrix is called nilpotent matrix. Okay. So here I give one example. You try yourself, check whether this matrix is nilpotent or not. Whether this matrix is nilpotent or not, and also find out the index of the matrix. Next is involutory matrix. Okay, involutory matrix. So a square matrix is called involutory matrix if a square is equal to I. Okay. So if a square is equal to I, then we can say that this matrix is what? Involutory matrix. So this one I give one example. See here, A is given. So A square means A into A. So after simplifying this, we got this one. AB minus AB, it is 0. AC minus AC, it is 0. Here one condition is given, a square plus bc is equal to 1. So in place of a square plus bc we put 1. Here also in place of bc plus a square we put 1. That means we got one identity matrix. Clear? We got a square is equal to I. Clear? So this kind of matrix is called involutory matrix. Okay? So that's all for today. So today I give some simple definition of matrix. So tomorrow I'll start how you can find out the inverse of a matrix by using elementary row and column transformation. Okay. Now ask me if is there any doubt. Anyone? Is there any doubt? This portion is very important. So ask me if is there any doubt. Anyone? Asif, tell me what is an idempotent matrix? Asif, anyone tell
Yes, sir.
what is an idempotent matrix? Anyone tell me what is an idempotent matrix? Yeah, tell me, anyone.
Sir. Hello, sir.
Yeah, what is an idempotent matrix?
Sir, a square matrix is called an idempotent matrix.
No, all square matrix is not called an idempotent matrix. When a matrix is called idempotent, if anyone tell me. Suraj?
If a square equals to a.
Yeah, good. If a square is equal to a, then the matrix is called idempotent matrix. Now, is there any doubt in nilpotent matrix? Anyone? Okay, then nothing. Okay. So the time is already running out because only 40 minutes we can take a video class. So that's all for today. So tomorrow I'll start how we can find out the inverse of a matrix by using elementary row and column transformation. Okay. So right now you give your attendance in our group, but you have to submit it before 10. Okay. But you have to submit the attendance before 10. Okay, then that's all for today.